Okay, welcome to this enrichment topic on clock arithmetic. It's also known as modular arithmetic, and you'll find we're going to use the word mod a lot of the time in this topic. Look, you're already familiar with a 12-hour clock for telling the time, so that's what we're going to build our information on at the start. So let me just draw up a bit of a clock here for you. We've got 1 o'clock, 2 o'clock, 3 o'clock, and so on. And now instead of 12, I'm just going to put 0. Like if you start off the day at midnight, that'll be 0 hours, and then 1 a.m., 2 a.m., 3 a.m., and so on. In fact, you might be familiar with 24-hour time. So you get around to midday, which is 12 o'clock. So I'll just pop that up on here, 12 o'clock. And then it goes to 13, 14, 15, 16, and so on. Now these numbers here all have equivalences in the 12-hour time, don't they? So 20 would be the same as 8. Like 100 hours would be the same as 8 p.m. But 20 turns out to be the equivalent to 8, if you like. And we have a special word for this equivalence in modular arithmetic or clock arithmetic, and this word is congruence. So I would say that 13 is congruent to 1 if you're talking about modulo 12. That mod there is modulo, and it's just saying if we're operating on a 12-hour clock, basically, if that's what's happening. So 14 is equivalent to 2 on a 12-hour clock. 22 is equivalent to 10 on a 12-hour clock. And what if we kept counting around the clock? What if we kept going? So that's 24, that's 25, that's 26, and so on. You would notice that 27, which we're not familiar with because normally 24-hour time is where we end up, but 27 would be the same as or congruent to 3 mod 12, wouldn't it? 27 would be congruent to 15, but we want to give it to the smallest value. So a value that's either 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. They're the final values we want to state. So 27, whilst it's congruent to 15, it's given as being congruent to 3 mod 12. So I wonder what 40 would be congruent to. Now you could keep counting around the clock until you get to 40, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Okay, so it's pretty clear 40 is congruent to 4 mod 12. But is there an easier way than counting all the way around the clock? That's the question you've got to ask yourself, because if I asked you about 100, for example, what would that be, mod 12? You don't want to be counting around and around the clock until you've listed all the numbers up to 100. So there must be an easier way. And it turns out that it's worth considering the fact that it's all about remainders. If we're talking modulo 12, it's all about remainders when we divide by 12. For example, 13, we said 13 was congruent to 1 modulo 12. What we're saying is if you divide 13 by 12, you'll get 1, but importantly the remainder is 1. And that's the thing that I'm interested in, that remainder, right? That remainder there of 1. 27 divided by 12, well, 2 12s are 24, and the remainder is 3. And it's the remainder I care about. 40 if you divide 40 by 12, well, 3 12s are 36 and the remainder is 4. Can you see how it's 40 is congruent to 4 mod 12? You don't have to count round the clock. You can just look at the remainders. So in answer to my question about 100, what about 100? 100 is congruent to what mod 12? You don't need to count round the clock. You simply need to work out the remainder. So I'm going to work out that now. What is 100 divided by 12? Well, 8 12s are 96, so it's 8, remainder 4. Therefore, since the remainder is 4, 100 is the same as 4 mod 12. Now let's consider a different modulo. How about we try modulo 5? So just get yourself a new page here. I'll draw up a bit of a clock. If I can get the pen to do this for me. Here we go. So, modulo 5, we start with 0 at the top here, and then 1, 2, 3, 4. Okay, my clock's not the best. Now 5 would actually be up here, and 6, 7, 8, 9, then you've got 10 hanging around up here, 11, 12, 13, and 14, and so on. So modulo 5, we're able to work some things out. For example, 6 is congruent to 1 modulo 5, or mod 5. That's because if you divide 6 by 5, you get a remainder of 1. So what about 13? You can see that on my clock. 13 is congruent to 3 modulo 5. If you divide 13 by 3, if you divide 13 by 5, it'll go twice to equal 10, and there'll be 3 remaining. And it's that remainder that matters, which means I can give you some bigger numbers, and you can work out what they are modulo 5. For example, let's work out, say 20 modulo 5. So 20, what's the remainder? 20, 5 goes exactly into 20. So 20 is congruent to 0 mod 5. When anything's congruent to 0, it means that 5 goes exactly into it, or whatever the modulus that you're working with goes exactly into that number. So I can tell you a whole lot of other numbers that would be congruent to 0 mod 5. 5, 10, 15, 20, 25, 30, because 5 goes into those exactly. They'd all be congruent to 0 mod 5. So the numbers we use, we would say that all the numbers, and we're talking whole numbers when we're working with moduli and number theory and stuff, all numbers are congruent to 0, 1, 2, 3, or 4 if you're working modulo 5, right? I'll write modulo 5, but you can just say mod 5. All numbers. So you give me a number like 53, and I'll tell you it's 3 mod 5. All numbers are congruent to either 0, 1, 2, 3, or 4 modulo 5. So that's how the modulus stuff works. Now,